A group of universities from the north of England are collaborating with scientists from Argentina under the theme of innovation for food security. We are looking for opportunities for our science to be useful because we have to produce more food in the world in a sustainable way.
The initiative of the Rutherford projects is about linking up SMEs, small businesses in the UK, with scientists in the UK and scientists in Argentina, the end users of this information.
So we designed a fellowship program that will attract these early career scientists to work under this scheme. They started working with academics from Lancaster University, and they developed further these ideas working with small companies and engaging academics from the NA AgriFood program. So they developed very innovative projects.
We are working with a company that is developing soil moisture sensors. We are trying to develop our own sensors based on open source hardware and software, and having the opportunity to interact with an enterprise that has done what we are trying to do. We are learning from their experience and we are gaining time.
So we're here today with Lancaster University to take our probe that we've developed into the real world and set it up both in the environment we've got here and also in the lab.
The thing that makes this sensor special is that we'll do a profile moisture content. It will measure all the way down from the surface to 50 centimetres, but it will also link that data through radio telemetry. And this is a very much cutting edge technology because it means the sensors are low power, plus the data transfer costs are also incredibly cheap compared to the technologies that we're using today.
What they're testing for us is how does that probe respond to the water in the ground, and how reliably does it actually respond to that water in the ground, so we can build a picture of a large network and what's happening underground.
We need soil moisture as hydrologists in terms of understanding how wet a catchment is and to understand therefore how it will respond during a flood. We also need it in terms of agriculture and understanding when to irrigate and so on within agriculture.
I didn't realise that there was quite such a need in Argentina for this kind of technology. They have a farming community which needs to understand more, and they're moving technology forward fast. And the kind of stuff that we're developing, which is low cost, high volume and low maintainability, is the sort of product that they actually need to get out there, to give them the information to improve their farming and help with their farming techniques.
The Argentinian global food sector is critical for the global food system. So supporting a stable global supply is on everybody's interest.
Within the UK, we import a lot of soya from Argentina. It's been recognised that climate change is increasingly going to constrain the yields of this crop within Argentina. So consequently, we can help provide insurance to the UK's food supply by cooperating with scientists in Argentina to actually make their crops a lot less stress sensitive. So we're interested in improving cold tolerance, which will be important in the UK, drought tolerance, which will be particularly important in Argentina, and we're also trying to improve the plant's ability to acquire its own nitrogen.
This project aims to develop non-GM genotypes, which is very important for Argentina because we have 30 million of hectares sown with soybean, but they are always dependent on GM soybean, which involves loads of use of glyphosate, which is a herbicide that has lots of environmental consequences.
We've got three partners within this project. One is the University of Rosario, and they bring a wealth of experience in working with this particular crop and allow us to implement drought stress studies in field experiments. We're also working with the Rutherford Fellows, and Mariana Antoinetta is doing some work on cold tolerance of soybean, and her expertise allows us to do a series of experiments that otherwise we would not have had the resource to do. We're also working with Plant Impact, who are a UK business selling biostimulant products to companies within South America. These can improve the stress tolerance of the crop. We've got some plans also to collaborate with Leeds University, and they have developed some soybean lines that show some very interesting drought stress responses.
We believe that this is a model that anybody can use. We believe that scientists and academics can work successfully with the private sector. They just need to listen what the needs are and come up with innovations. I'm convinced that this is something that anyone can try.